Okay, so in this problem, I have a column or a pipe, okay, that's subject to a 5 kilonewton load, okay, and basically that pipe is then set on top of kind of a base plate, which is then attached to kind of a concrete pedestal that I have there. Okay, so I've got the dimensions on here. You can see that T is 5 millimeters, R of the base plate is 150 millimeters. So I want to determine what the factor of safety are for both the steel base plate as well as the concrete. Okay, and I know that the failure stress for the steel and concrete are 350 and 25 megapascal, and this is going to be in a bearing sort of a situation, right? Because I got that column. I'm looking at the interaction between the pipe and the base plate, and then the base plate and the concrete pedestal. So the first thing I need to do is figure out those areas, which will basically be the area between the pipe and the pedestal, or I'm sorry, the pipe and the base plate, and then between the base plate and the concrete, and that's what I have here. So at the concrete base plate, it's simply just pi r squared, where r is 150 millimeters. Okay, whereas at the steel, between this, the two steel pieces, it's going to be basically the area of the pipe, which is going to be pi outer minus inner radius squared, which is what I have right there. So those are my areas, my bearing areas between there. So first thing we'll do is we'll look at what that stress is on the concrete, which is going to be my load 500 divided by, again, that bearing area that I just found previously. So again, so I got 500 kilonewtons divided by this area that I have here, which gives me a bearing stress of just above 7 megapascals. Okay, so again, this is for the concrete. So basically finding the ratio between that and the 25 megapascals gives me my factor of safety. So I just take that 25, which is what I know that concrete fails at, okay, and divide it by the stress that I'm seeing, and I actually get a factor of safety about 3.5. So do the same thing for the steel. This time I just take that 500 kilonewtons and divide it by the pipe area, which we calculated up here. Okay, and then I take that and compare it to the 350 megapascals, which is the bearing failure stress for steel, and I basically get 2.14. So again, bearing stress is the interaction between two surfaces in contact. So I figured that out for both between the pipe and the steel, and then the base plate and the concrete, found this stress, and then compared that to the failure stress that I know to figure out what the factor of safety is for this sort of a loading.